Before knowing the causes of mineralocorticoids, let's know the names of mineralocorticoids. First is aldosterone. Aldosterone is very potent mineralocorticoid. It accounts for about 90% of the total mineralocorticoid activity. Next is Deoxycorticosterone. It is 1/30 times as potent as aldosterone, but it is secreted in very small quantity. Corticosterone and cortisone, they have slight mineralocorticoid activity. 9-alpha fluorocortisol, it is synthetic mineralocorticoid and it is slightly more potent than aldosterone. Cortisol, it has slight mineralocorticoid activity. It is 3000 times less potent as aldosterone, but its amount is 2000 times more than aldosterone, so it can activate the mineralocorticoid receptors. But normally in our body, cortisol cannot activate mineralocorticoid receptors because in kidney it is converted into inactive compound cortisone by 11-beta-hydroxysteroid dehydrogenase type 2, and this cortisone it cannot stimulate, or it has slight mineralocorticoid activity. So in this list, most potent mineralocorticoid naturally produced in the body is aldosterone, but synthetic mineralocorticoid, which is again more potent than aldosterone, is 9-alpha fluorocortisol. This diagram shows the interconversion of active cortisol and inactive cortisone. In the cells of these organs, kidney, colon, sweat and salivary glands, 11-beta-hydroxysteroid dehydrogenase type 2 enzyme is present. And in the cells of these organs, liver, skin, brain, adipose tissue and pancreas, 11-beta-hydroxysteroid dehydrogenase type 1 enzyme is present. So type 1 is present in the cells of these organs and type 2 isoform is present in the cells of these organs. So now in these organs, active cortisol is converted by type 2 enzyme into inactive cortisone. And this inactive cortisone, it cannot activate the mineralocorticoid receptors. So cortisol cannot have its action on the cells of these organs. But when this cortisone is transferred by blood into the cells of these organs, this inactive cortisone is again converted into active cortisol by enzyme 11-beta-hydroxysteroid dehydrogenase type 1. This active cortisol, now it can easily activate the glucocorticoid receptors present in the cells of these organs. And again, when cortisol is transferred back through blood into the cells of these organs, again it is inactivated. So it shows that cortisol, it has its action on the cells of these organs but cannot have its action on the cells of these organs because of the isoform expression of different isoforms of the 11-beta-hydroxysteroid dehydrogenase type 2. Causes of mineralocorticoid excess can be classified as primary hyperaldosteronism, secondary hyperaldosteronism, and non-aldosterone dependent activation of mineralocorticoid pathway. Let's first see the primary hyperaldosteronism, its causes. Here are shown in the kidneys, and in the upper pole of the kidney are the adrenal glands. So if there is intrinsic abnormality of the adrenal glands, then it is called primary hyperaldosteronism. So what are the causes, what are the intrinsic abnormality of the adrenal glands that cause the primary hyperaldosteronism? So here are some 3 causes. The first one is idiopathic bilateral adrenal hyperplasia. There is hyperplasia of the aldosterone producing zona glomerulosa cells, and bilateral is more common than unilateral adrenal hyperplasia. Second cause is aldosterone producing adrenal adenoma. So it is a benign tumor that increases the production of aldosterone, and this is also known as Cone syndrome, and it is mostly solitary. Third cause is the glucocorticoid suppressible hyperaldosteronism. In this glucocorticoid suppressible hyperaldosteronism, ACTH, adrenocorticotropic hormone, it stimulates the zona fasciculata and zona reticularis to secrete aldosterone. Actually, fasciculata and reticularis, they do not secrete aldosterone, But in this disease, ACTH stimulates these two layers, fasciculata and reticularis, to secrete aldosterone. Why this is called glucocorticoid suppressible hyperaldosteronism? The reason is, if dexamethasone is given, then it will suppress ACTH, and when there is less production of ACTH, then fasciculata and reticularis will not be stimulated to produce aldosterone. So the causes here are idiopathic bilateral adrenal hyperplasia, which is the most common cause, aldosterone secreting adrenal adenoma, which is also known as Cone syndrome, and glucocorticoid suppressible hyperaldosteronism. In primary hyperaldosteronism, there is intrinsic abnormality of adrenal gland. So aldosterone is high. This high aldosterone will suppress renin by negative feedback. So in primary hyperaldosteronism, renin will be less and aldosterone is high. Now let's see secondary hyperaldosteronism. In this category, there will not be intrinsic abnormality of the adrenal glands, but they will be extra-adrenal. The first cause of secondary hyperaldosteronism is decreased renal perfusion. So renal perfusion can be decreased in the diseases like heart failure, liver failure, renal artery stenosis, or when there is hypovolemia. And second cause is renin producing renal tumor. So first one is decreased renal perfusion and second one is renin secreting renal tumor. So what happens to plasma renin and aldosterone in secondary hyperaldosteronism? So here first, renin is high. High renin will stimulate the adrenal glands to produce high aldosterone. This aldosterone tries to suppress renin by negative feedback, but it cannot, because here the source of production of renin is the cause of disease. That's why renin is high and aldosterone is also high. Next is non-aldosterone dependent activation of mineralocorticoid pathway. So renin and aldosterone both are decreased in this category. So this seems paradoxical, but I will explain the reason. And here the causes are licorice misuse. Licorice inhibits the enzyme 11-beta hydroxysteroid dehydrogenase type 2. That's why cortisol will be high and it cannot be converted into cortisone in the kidney. So cortisol has the mineralocorticoid activity and it will stimulate the mineralocorticoid receptors. Next is Liddle syndrome. It is an autosomal dominant syndrome in which there is constitutive activation of epithelial sodium channel protein present in the luminal membrane of principal cells. Next one is Deoxycorticosterone secreting tumor. So Deoxycorticosterone is also potent mineralocorticoid. So this, however, this is very rare. It's not common. So when there is activation of the mineralocorticoid receptors, the effects are like that of aldosterone. That's why renin will be suppressed by negative feedback. When renin is less, it cannot stimulate aldosterone, so aldosterone will also be less. So by investigating the plasma renin and aldosterone, these categories can be easily differentiated.